Hello everyone, and welcome to our presentation. Today, we will talk about creativity in AI-generated visual art and how it can be evaluated. Before we start, I have a simple question. Which artwork do you think was created by a real human artist, and which one was generated by AI? Today, AI-generated art has become very realistic, and many people cannot easily tell the difference. In recent years, AI models like Stable Diffusion, DALL-E, and Midjourney have changed digital art generation. These models can create high-quality images from simple text prompts. However, evaluated AI-generated art is still difficult. Most current evaluation methods focus on realism, image quality, and prompt matching, not creativity itself. Because of this, our research focuses on creating a framework to evaluate creativity in AI-generated visual art. The main problem is that existing evaluation metrics were not designed to measure creativity. Metrics such as FID, Inception Score, and Clip Score mainly measure image quality and similarity to existing images. As a result, AI can achieve high scores even if it was only copying existing artistic styles. So, our main research question is, how can we evaluate creativity itself instead of only realism?
Now I will explain the proposed framework and system architecture. We proposed a framework called the Computational Creativity Triad or CCT to evaluate creativity in AI generated art. The framework measures creativity using three dimensions: novelty, value, and surprise. Novelty measures originality, value measures artistic quality, and surprise measures how unexpected the artwork is. For the system architecture, the image is processed using a clip and DINOV tool to extract visual and semantic features. Then the system evaluates the image based on the three creativity dimensions and combine the results into a final creativity profile. For the experimental setup, we used 180 images, including human artworks from WikiArt and AI generated images from SDXL Turbo. We also compared our framework with a common evaluation matrix like FED and Clip Score.
In this section, we'll discuss the results of our framework, which showed clear differences between the human-created and AI-generated artwork. The AI-generated images achieved higher scores in all three creativity dimensions, which were novelty, value, and surprise. In the novelty dimension, AI images appeared much more visually different from the WikiArt reference dataset. Their separation was very strong. For the value dimension, which measures aesthetic quality, AI-generated images also scored slightly higher, although the difference was smaller compared to novelty. In the surprise dimension, the AI images again achieved higher scores, meaning that they appeared more unexpected relative to the reference distribution. To verify that these differences were meaningful, we performed statistical tests, and all the results achieved p-values below than 0.001, confirming that the differences were statistically significant. The box plot and radar chart also clearly visualized these differences, with AI images covering a larger creativity profile across all the three dimensions. Finally, we compared our framework with traditional baseline metrics, which demonstrated that our framework provides a more structured and multidimensional way to evaluate creativity itself rather than only measuring image quality or prompt alignments.
So our results showed that AI-generated images scored higher in novelty, value, and surprise. However, this does not automatically mean that AI is truly more creative than humans. One important reason is that creativity evaluation depends heavily on the reference dataset used during the experiment. In our case, we used WikiArt as the human art reference dataset. And WikiArt mainly contains traditional and classical artwork. Because of this, modern AI generated images appeared more unusual and visually different when compared to the dataset, which increased their novelty and surprise scores. This means that creativity evaluation is highly influenced by the context and comparison standards. Overall, our findings suggest that AI can produce output that appear creative computationally, but human creativity still includes emotional and cultural aspects that are difficult to measure using numerical metrics alone. Our study had several limitations. First was the dataset size was relatively small, which may affect the accuracy of the results. Second, the dataset was based towards Western art style, meaning other cultures were less represented. In addition, human validation was not included, so the evaluation relied mostly on computational metrics. For future work, we plan to expand the dataset, test more AI generators, and include human expert evaluation to achieve more balanced creativity assessment. In conclusion, current AI evaluation methods mainly focus on realism and image quality, while creativity is often overlooked. To address this issue, we introduced the Computational Creativity Trade, or CCT framework, which evaluates creativity using novelty, value, and surprise. Our findings show that AI-generated art can be evaluated in a more structured and multidimensional way, while also highlighting the importance of the context and human interruption in creativity assessment. This concludes our presentation. Thank you all for listening.